All right, we're back on the air conditioning for this 2019 Ford F-150. And what I'm going to show you is something different. I'm going to show you how the superheat changes through the internal heat exchanger. This has an internal heat exchanger. If you look right here where my finger is touching, that is the liquid line entering the internal heat exchanger. Do you see that pipe right inside there? That's your suction line. That's your liquid line. Then it exits out over there. You could see my temperature probe, the yellow probe right there that you can barely see. I'm on the suction line coming out of the evaporator, but just after that, a few inches, is where the liquid line comes back out of the internal heat exchanger. Let's see if I could get you a better view down here. Okay, that's my temperature probe, but I can't really get you a good view of what you need to see, but it Y's out of there. So we're going to pay attention to the temperature of the suction line coming out of the evaporator. So the temperature is 49 degrees at that clamp at the suction line coming out. But also coming out of there is the liquid line. So there's being heat added afterwards. So look at this, 48 degrees at that point. And at that point, it's giving us a superheat of 10. That's what you think you would have going back to the compressor. Now that's at the evaporator, but that's really not true because you're having heat. There's heat being added from the evaporator. It's changing the condensed liquid line. So there's an exchange of heat through the internal heat exchanger. Now watch what happens when I move it. I'm gonna go grab that sensor and I'm gonna move it right here. This is after the internal heat exchanger. You're gonna see the temperature change. This is the temperature going back to the compressor. So, and it can't be painted. It has to be bright, shiny metal. So there I go. Now I'm attached at this point. This is after the internal heat exchanger. Now the temperature is 55 degrees and our superheat's 18. Okay, now let's look how the subcooling changes. So here's the temperature of the refrigerant. It goes in as a hot vapor right here. Then it's making its multi-passes. Then it's going into, there's a little port somewhere right in here. Okay, somewhere right in this little area, there's a port that is drilled to go to this receiver dryer that has the desiccant material, so it can separate out the refrigerant oil as a liquid down, and it goes through a screen right here and it drops down through a port. I've done videos on this where I've cut these open in half and I cut this open in half and I cut that line to show you how the ports change. And then right here, I think it's right between these dimples. So nope, that's not a seal. 1, 2, 3, 4. I think it's somewhere 3 or 4. There's a hole down here, and only this last one way down here, that's a solid piece of metal. That's not a fin. I mean, that's not a tube. That's a solid piece of metal. But this is a tube, and the next one's a tube. So these 3 or 4, there's a little hole cut down in the bottom of here. This is filled with liquid. And so the liquid and the oil are only going through these last few tubes. And this is getting subcooled right here. This is doing the subcooling of the condenser. It's all liquid. It's getting the last BTU possibly out of that liquid. So it's rejected its energy. It's rejected the heat, and it comes out here cooler. But they make it a little more efficient because YF refrigerant is just a little less efficient than 134. So what they do is they take this and they run it in right here at the internal heat exchanger. That is a pipe wrapped around a pipe on the subcooling. So let's look at this temperature. This temperature right now coming out is 60 degrees. Right there. We got a 12 degree subcooling. Now, watch what happens when the cold liquid refrigerant absorbs heat out of that liquid refrigerant that's 60 degrees, and it gets to that other little tiny, let's see if I can make it focus over there. Let's see if I can zoom in. Now watch my finger. See where my finger is just touching that little aluminum line right there? Right there, that little line. That is coming out of the internal heat exchanger and it should be colder when we take the temperature. So take a look again. 60 degrees right there. And of course Apple doesn't want to focus. Let me get up there. You see it go yellow. You see that yellow blinking? That means there's no contact. Then it makes good contact and it turns green. Can you see it blinking green now? That means you have made contact. If there was paint on that, you would be not making contact. Now look at the temperature. 57 degrees. Right here. So it absorbed some energy out of the liquid refrigerant, and it gave it a little bit more subcooling, so there's a little more potential energy per pound of refrigerant flowing to the expansion valve to absorb more heat out of the evaporator. It makes this refrigerant, by using that internal heat exchanger, it makes the system a little more efficient. I hope that's enough for now. I got to get going. I'm about to hop on the plane tomorrow morning, and so this is my last shop of the day. And I'm getting ready to go to Florida to the HVAC Symposium, Brian Orb's HVAC Symposium, for, was it 2 or 3 days? All commercial and residential, building science, you know, passive house kind of stuff, energy efficiency, all that kind of stuff. A bunch of guys who get together who are like-minded, who really want to learn to better the industry. Not salesmen and scam artists who are looking for the little blue lights to stick in HVAC units, or the quick sealant crap to put in, or some super splooge to put in there to say it makes it more effective. Not those type of people. This is a congregation of people who just want to do better in the business itself. Not scam artists, salesmen who are looking to go to seminars to get 1,000% more profit. Guys who truly want to get better. 3 days, Brian Orb's HVAC Symposium. Look it up on the internet. And that's where me and my son are going, and we're leaving tomorrow morning in the next 12 hours or so. All right, see you guys.